I'm sure you guys have heard of a bell curve, right? At some point in your life, you've heard of a bell curve.
I've heard of bell.
Yeah, that was in our homework.
Bell, bro. Bell. B-E-L-L.
Oh, I thought you said
bell curve. Bell curve. So a bell curve is a general way of measuring data. Okay, so remember we talked about distributions the last class, which is how the data items look spread out, right? So that's our distribution. A normal distribution is one where it's a distribution where the mean, the median, and the mode are all equal. Okay, so ideally, that's what we would like, right? So if our mean, our median, and our mode are all equal, then we have a nice set of data, right? We're looking at the prices of houses on a block, and the mean, the average price, the median price, and the mode price is called a normal distribution if all those values are equal. Okay, so it's called a normal distribution. Sometimes the normal distribution is referred to what we call as a bell curve. And the reason it's called a bell curve is if we were to plot all the data values, it would make a bell curve. I'll show you. So you are going to do that. It looks like a bell, right? Like a, you know, like a Liberty Bell kind of thing.
Oh.
I mean, it looks like a hill, but yeah.
Okay. So we're going to put a number line right here. This center value is going to be your mean, which is also your median and also your mode, right?
Is this like the box thing?
What's a box thing?
Last semester I took fine art math and she did this box thing.
The 5-point summary that we did last class? Yeah, we did that last class where we did 25% of the data in quartile 1, quartile 2.
Okay,
Do you remember that?
Seeing this.
Okay. All right, so this is a bell curve. And so here's your mean, right? And if I were to look at all the data values, then I can find a standard deviation. And the standard deviation is the average space that each data value is from the mean, right? We talked about that last class. So you can have a value that falls right here, right? And it would be maybe however many standard deviations from the mean. And you can be below the mean, a standard deviation below, you can be a standard deviation above, right? You remember all that? Okay, so here is going to be one standard deviation. Let's do it like this. That's a cool little line, huh? Okay, so that's one standard deviation from the mean. So any data point that falls between this value and the mean is going to be one standard deviation away, right? And so then we also have two standard deviations. So any data value that falls within that space is going to be two standard deviations from the mean. Just to kind of show you what's going on, the mean is going to be some value. So like the average price of the house is $200,000, right? So 200,000 would be here. And then whatever one standard deviation would be, if a price fell within that range, it would be one standard deviation away, and so forth. And then you have three standard deviations. So far, so good, right? Okay, so in a normal curve, 68% of your data is going to fall within one standard deviation. Always? Always, yes. This is stuff to memorize, okay? 68% of your data is going to fall within one standard deviation. I think, like, just memorize it and be really familiar with it, and I think on the test, like, they have a problem with the information, so you can use the test to take the test kind of thing, right? 95% of your data falls within two standard deviations. And then 99.7. 99.7% of your data falls within 3 standard deviations. Okay? So that means 0.3% of your data will fall outside of this bell curve, with further away than 3 standard deviations. Alright, so let's look at an example. Example 1. For a normal distribution, the mean is 240. And the standard deviation is 12. How many standard deviations is the data value (270) from the mean?
Set up a proportion.
Okay, so what we're saying is that the mean, if you think about the bell curve, right, the mean is here at 240. Each standard deviation is 12 points, right? So 1 standard deviation would be 252, right? 2 standard deviations would be 264.
Wait.
If this is the mean, you don't have to do this to solve the problem. I'm just trying to show you a visual of what's going on. So here's your mean. 12 points is a standard deviation. So 240 plus 12 would be 1 standard deviation, right?
Okay.
240 plus 12 plus 12 would be 2 standard deviations. So that's 264, right? Another standard deviation would be 276, right? You with me?
So you just keep adding 12.
Right. Each standard deviation is another 12 points away.
Okay.
Okay. So we're looking to see where does this 270 fall?
In between.
Right.
So, well, no. So what we're going to do, this is how we're going to solve it. We're going to do 270 minus 240 equals 30, right? How many sets of 12 are in 30?
2.
Try it in your calculator.
2.5. 2.5.
I think it's 2.5. So we're going to say it is 2.5 standard deviations above the mean. Okay, because remember, we can be below the mean, correct? So we're 2.5 standard deviations above the mean. Higher than the mean. Yes? Yes? So you don't have to do this right here to solve the problem. I just wanted to show you visually what is going on. Okay, all you need to do is subtract the value from the mean and then divide by the standard deviation. Okay, so letter B, so the same problem, letter B. A score of what is 2.5 standard deviations below the mean? A score of what is 2.5 standard deviations below the mean?
210.
210. The way that I would do it is I would look at the mean, which is 240, and I would subtract 1 standard deviation, subtract 2 standard deviations, and then subtract half. Or you can do 240 minus 2.5 times 12, right? Same thing. But I like to do this because my mind processes that a little better. So the answer is 210. We're good? Yes?
Yeah.
All right. Example 2, I want to keep up here. So I'm going to do example 2. Women's heights. It's hard to say. Heights. Average 69 inches with a standard deviation of 2.8 inches.
What?
In what range will the middle 99.7% lie? Blank and between. Okay, so if you look at the bell curve, right? 99.7% of our data falls between how many standard deviations?
3.
3, right? So what we want to do is we want to figure out how much is 3 standard deviations. How many points? So each 1 standard deviation is 2.8. So 3 of those is how much?
8.4.
8.4.
Is it 2.8 times 2?
Yeah. Okay. So if our mean is 69, we add 8.4 to get the above the standard deviation, and we're going to subtract 8.4 to get the below. Does that make sense to you guys? 99.7% of my data is falling 3 standard deviations away from the mean. Each standard deviation is 2.8. So if my mean is 69, I do minus 2.4, minus 2.4, minus 2.4 to find the low end. And then I'll do plus 2.4, plus 2.4, plus 2.4 to find the high end. Yes? No?
Mm-hmm.
Why are you looking at me like that? Like, no?
Yeah.
Oh, yeah. Okay, so that gives us what? I didn't do the math, so, and I am not going to think that through, because I hate decimals. 60.6 and 77.4. So 99% of all women will fall between 77.4 inches and 60.6 inches. Huh? 2.8. I'm sorry.
I was just like,
Yeah, I definitely said 2.4, but I meant to say.
Kill me, schools.
Y'all, I had a professor, no kidding. I think it was differential equations. So you take in your math progression, you take like calculus 1, calculus 2, calculus 3, and then after your third calculus, the next math is called differential equations, right? And so I'm in this class, and the professor, like, it was wild. So he would do like the calculus part, and then he would go algebra, 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 and there's the answer. And so we would say, like, and then it was multiple choice, okay? So like it was choice A. And then we would say, it's not A, it should be B. He was like, oh yeah. He's like, you gotta watch me because I'm gonna say the answer's A, I'm gonna think it's C, but it's really B, and I'm gonna write D. And I'm like, what? Like, how are we? And I'll never forget that because I remember sitting as a student thinking, how am I going to pass this class? I have no idea what he just said. Anyway, so
You don't even know what he just said.
I'm going to say 2.4. I'm going to think 2.6. I'm going to see 2.8, but it's really 2.9, right?
So what is that in feet? How many feet is that?
Divide it by 12 and find out. I don't know.
Oh. 5.5.
There you go. I'm between that range.
Sure.
Okay. So y'all kind of get an idea of standard deviation. Yes? 69 minus 88.4, 60.6 inches and 77.4 inches. Yes? So we're all good. Okay. So the next thing we're going to talk about is what's called a z-score. A z-score describes how many standard deviations a data item lies above or below the mean. Let's see, that's a z-score. So the first thing is a z-score for the mean is 0. And to find the z-score equals the data item minus the mean divided by the standard deviation. If you are above the mean, your z-score will be positive. If you are below the mean, your z-score will be negative. And the way I like to describe z-scores is every set of data items has standard deviations, right? If we're looking at data values. So let's say that we're talking about the number of completed passes each quarterback makes in the NFL, right? And then we're given the average for each quarterback, right? And so each quarterback will receive a z-score based on the data items, based on the standard deviation, which is based on the average of each one, right? So we use this complicated formula to find out the standard deviation, and then however many standard deviations you are away from the mean, you're given a z-score. Okay, so Drew Brees has a z-score, right? And then now let's go to this car dealership, and we're talking about how many sales this salesman makes in a season, right? From fall to spring or something. And so each we do all the data items, we find out the standard deviation, and then we look at the salesman, and the salesman has an average, and that's certain amount of standard deviations from the mean, and so he gets a z-score, right? So who's better, Drew Brees or the salesman? Well, ideally you can't compare them because completing passes is not the same thing as selling cars, right? But if they both have a z-score, now we're putting them on the same playing field. And whoever's closer to the average would have the better z-score, right? So you can compare things that aren't comparable. So that's kind of what z-scores allow us to do, is to compare you or the data item based on the average of those data items, yes? So you can cross things that aren't comparable and actually compare them, yeah? And that's the idea of a z-score.
That was a lot.
Huh?
That was a lot.
Do you understand what I'm trying to get at? Just because
So you can compare things that
that aren't comparable. Yeah. That aren't comparable. Okay. So example number 3. Let's look at this one. The math to support it is complicated, but not in this class. In this class it's simple. We don't really go into it. Example 3, for a normal distribution. For a normal distribution. Do y'all talk to Velma?
Yeah,
Somebody gonna tell her that we're not having class, or should I email her?
yeah, she'll know.
Okay.
She's sending her the note.
And the standard deviation of 32
That says you're on campus.
converts the data value 176 to a z-score.
Did you say 276 or 176?
176.
Okay.
I wrote 176 and I said 176. Well, I don't know what I said, but it's definitely 176.
Okay.
I don't know what came out of my mouth.
For a normal.
All right, so this is quite simple, right? The formula is given here. To find the z-score, you just take the data item minus the mean divided by the standard deviation. So we have a z-score, and that's what we're trying to find. So we're trying to find our z-score. And we know that that's equal to the data item, which is 176, minus the mean, which is 240, divided by the standard deviation, which is 32. So what is your z-score?
A number.
Is that a point behind the 32 or no?
It's a period.
Okay.
I know. Who uses grammar anymore? Alright, so let's
So
see.
170.
176 minus 240, enter, divided by 32. So negative 2. So your z-score is negative 2. Okay, the negative indicates that you are below the mean, right? If you have a negative z-score, you are below the mean. 176 is below the mean of 240, right? It's the less. Go with me? Okay. Example number 4. For normal distribution, the mean is 900. The standard deviation is 60. Find the data item that corresponds to z equals 2.5.
That's algebra.
Huh?
She got to find the data. This
Now we're finding the data item. So we have a z-score is 2.5 is equal to some data item minus my mean of 900 divided by my standard deviation of 60. And so we are solving for x, the data item.
So would you do 60 times 2.5?
Yes, that's what I would do. And then add 900.
I can't almost do this.
What? It is. No, you just don't know it well enough. All right, so 1050, right? 1050 is 60 points above the mean for the z-score. Yes?
So tell me how you got the converted fraction to the math problem. Like 60 times 2.5, but what about after that?
Okay, so 60 times 2.5, what'd you get?
Because I'm just writing it down. I didn't get anything. I'm just writing down what I'm
Let's
supposed
see.
to do.
2.5 times 60 is 150.
Okay.
So 150 is equal to x minus 900. So then we add 900 to both sides.
Okay, thanks.
You're welcome. All right, one more example. Oh, wait, no. Two more things. Well, a vocabulary. Definition. In nth percentile, it's a definition. N-T-H, the nth percentile. The nth percentile is n percent of items in a distribution that are less than a particular data item. So Mindy, I'm going to use you as an example, okay?
Okay.
Last class, she showed me her son's test scores, and in one of the areas, he scored in the 98th percentile. Okay. So her son scores a particular data item out of all the students that took this test, right? He's in the 98th percentile. What that means is his data item is located somewhere on the set of data. 98% of the other data items fall below where his data item is, or less, right? So 98th percentile means that 98% scored less than that particular data item, or that particular score.
So would that be the same thing as saying mean?
No. The mean's the average. Okay, so you'll see a lot of times when you're taking standardized tests, they will give you a percentile ranking. A lot of times, well, I've never seen a test where they don't give you a percentile ranking.
Is there supposed to be than instead of that?
Scored less than, yeah. All right, a score in the 50th percentile so that means 50% is less, right? And 50% would be greater, is the median. Does that make sense to you? I don't feel that I need to even write that, but we do. Okay, if you are in the 50th percentile, then you are the median of the set of data, because half of the data items are less. What's wrong?
I was laughing.
You're laughing because I wrote that down?
Mm-hmm.
I still have to write it down. Good? Everybody understands this though, right? Okay, one more question. We're going to do an example. What example is 5?
Yeah.
4, 5? Okay. 5 is going to be a picture. So let me draw it.
You gonna draw?
I'm going to draw.
Are you an artist?
It's art.
No, I'm not. In fact, I've never taken an art class in my life.
I did, but my teacher said I was the worst artist he has ever seen.
Wow, that's pretty bad.
Well, he told that to my mom.
That was high school?
Yeah.
Oh, Lord.
Well, no, he said, I have a very interesting perspective, and my mom goes, we all suck at art with me. Because he's the worst student I've ever seen.
Golly.
Like, art-wise. Not like the English.
Somebody might like your art. You never know.
I know, really. It's opinion, right?
Mm-hmm.
Okay, so 24 in this data is going to be my mean. Here's my bell curve. Ooh, something like that.
I can't see anything today.
What's wrong with your eye?
No, it's just like the way you're standing, like.
Where I'm standing?
But it's fine. I got it.
Okay, this is the price in thousands. So 24,000, 25,000, 26, 27, so forth. And this is the number of cars sold. Alright, so here we go. What percent of buyers paid between 21 and 25,000. Y'all know that K means 1,000, right?
Yes.
Mm-hmm.
Well, if you don't know, you just learned it. Welcome to real life. So when you go out into the real world and you see a K, you'll be like, oh, Miss B told me these guys. Alright, so what percent of buyers pay between 21 and 25,000? Alright, so what we're going to do is,
Say 75.
yeah, okay. This 21 is 1, 2, 3 standard deviations right away.
Yep.
Are with me?
So that's like 99.7.
99.7, very good. Alright,
Then 25 is only one away.
right, okay, which was, do y'all remember that percentage?
68.
68. Okay, so this is 68% within one standard deviation. 68 divided by 2 is 34. You with me?
Why 2?
Huh? Half of it's going to be on this side,
Oh, yeah.
and
Okay.
half of it's going to be on this side. 99.7 divided by 2 is what?
49.85.
49.85. So let's erase this 99.7 and let's look at 49.85 and 49.85. Is everybody understanding what I'm doing? Yes?
Mm-hmm.
Okay. So between 25 and 21,000, what is that amount, that percent? Well, 49.85% is going to carry me from 21 to 24, right?
Mm-hmm.
And then 34% is going to carry me from 24 to 25.
You just add that?
Just add them. 49.85 plus 34. Which is 83.85%. And just round however the computer tells you to round. Yes? Alright, let me just ask another question about this data set. What percent of buyers pay more than 27,000? Pay more than 27,000. Any ideas how you could do that? Any ideas? You know that 99.7 pay between 21 and 27, right?
Just the last little bit.
So 0.3% paid above 27 and less than outside of this range. So what is 0.3 divided by 2?
1.15.
0.15. So 0.15 on this side and 0.15 on this side. Yes? Okay, do y'all understand how the percentages are good? Alrighty then. That's all I have for you. Yay. Alright, so you have a question which I will answer. I'm canceling class Thursday. Enjoy your break. When we come back on the Tuesday, we will review for test 3. The Thursday, we will have test 3. I will open up practice test 3 for the holidays. Okay, in the event that you want to study, it will be available to you. Okay. I'll leave this homework open until Tuesday when we come back. That way, if you have questions, you can see me and ask them before it's due. Yes, the beginning, yes.
Thursday as well.